What up, squad fam? Today we're gonna ferment some wine, some grape juice wine. I bought it off Robinson's. I'm not gonna use fruits because it's gonna be tedious and maybe more expensive than if you use the store-bought stuff. Yeah. So I'm using this. First, we need to start off with the materials. What we're gonna need is some cups, measuring cups. This is sterilized bottle, and actually we need to wrap it with some dark material. It's sterilized as well, as I said earlier. I boiled it in water. This is yeast, baker's yeast, and the juice I showed you, and this biolock, which is actually very simple to and very cheap to make. This is 5 pesos. This is 8 pesos off Shopee, I think, but it's gonna be expensive if you consider shipping, and some tack it to, lock it down later. And we have some data over here. So the data is like that. The amount of fruit mashed, it's 2 pounds to get that much juice, and I researched it. And after that, the fruit used is of course it's grape, and then the volume is 16 flow ounce, but I'm not gonna use all of it. I'm gonna use probably a cup or more. No, 1 cup only. So after that, yeah, as you can notice, it's deep purple in color, and the brand is Welks, so it's 100% grape juice, so you know it's going to be good. And I calculated it, and since 1 milliliter is equals to roughly 1 gram, I calculated it here based on the contents. So the percentage of sugar in this bottle is around 14.8% or 15%. So 70 grams over 473, roughly 500 ml, if that's considered. Anyways, so as you can see, these are the materials that we're gonna need, and that's all we need, and our brains. Now let me tell you how I make this. So basically, this is from this long tube. It's cheap, only 8 pesos. Yeah, and you just need to size it. I just made a loop. And then I cut it down to size to show it was boss. Yeah, and I drilled a hole through the cap of this thing. See, I used my father's drill, and I glue tacked it and put some wire here. This is the biolock. You're gonna put water inside that loop, so bacteria won't get in. But don't worry, my hands are sterilized. The table is also sterilized. Okay, sorry for the cut, but I got the teaspoon already. We're also gonna need that later on. And first, we put the funnel there, and now we're just gonna use this to measure out 1 cup of this grape juice. So I hope it's gonna be easy to open. There we go. It's hard. Okay. So 1 cup. Very nice. 1 cup of grape juice. There we go. As you can see, it's in a deep purple color. Anyways, now that we have that measured, we just need to put it inside of this. Okay? So you just need to pour it. Gently now. And we're gonna need a 1/4 teaspoon of it for that amount, for 1 cup of wine, as I researched via Cora in Google. Yes. And make sure you have this prepared already, and make sure that you have this cleaned. I actually cleaned it before. I heated up some water, then sucked it up so that it will be disinfected. so it's dead now, the bacteria, I mean. And this can be drank later. Okay, let me just pour this in here. But we have that inside, as you can see. Oh, we just need to mix it around. I hope it's getting mixed, and I hope I won't splash myself, because I've done this multiple times when I was drinking the original drink inside of this bottle, and when I did it this when I did this, it was terrible. Spilled all over me. Sucked. Okay, now that it's well mixed, we'll give it some time to rest, and I'll just biolock it after giving it some time to stop spinning. I think that's how you do it. So let me get this. Actually, as you can see, it has a opening there. I'm gonna fix it once I cap it there. Do that. Suck up that thing. Put it inside here. And then there. I think that's how it goes. No, wait. There's air pockets. That's bad sign. That's a bad sign, I feel. Let me get rid of that. I hope it gets rid of it. So I succeeded in procuring the biolock. So I got rid of the tiny air pocket there where bacteria might be in, and unfortunately there are tiny air bubbles there. I think it's because I used this. I pressed it too much, and I can't. When I press it, it just sucks in some of the air while the water is coming out of the tip of the dropper. So it won't be perfect, but it's a biolock. It's blocked still, and we just need to cover this bottle with some dark paper or something that's dark, and place it somewhere where it can't be disturbed, and wait for it to become wine. So that's gonna be fun. Let me shake it. Actually, some of the yeast are just on the bottom settling. So I've succeeded and effectively wrapped the bottle in some dark material so the yeast can do its magic. And I actually left this exposed so I can change the water or replenish it when need be. And now I'm just gonna put it on top of the ref and we're done. We just need to wait for 3 to 6 weeks for it to ferment. And after that, we're gonna be smooth sailing, gonna taste some wine, eat some cheese and crackers. It's gonna be lit. The formula for the fermentation process is this, which essentially translates to glucose being broken down by the yeast to be released as CO2 and ethanol as waste products. Now, to find out whether the equation is balanced or not, we need to count the number of each elements in the reactant side and the product side of the equation. So let's just put a line here to separate them. Now, the first step is to identify the elements present within the equation. So, looking at the equation, we can see that the products or elements present are carbon, hydrogen, and oxygen. Okay, now let's look at the reactant side. Notice for the reactants, there are 6 carbons, 12 hydrogens, and 6 oxygens, relative to the subscripts of those elements in the equation. Next, let's look at the right. See that there are 2 compounds, namely carbon dioxide, the first, and ethanol, the second. To know how many of each elements there are, we just need to sum it all up as shown. Summing up the elements, we will have 1 carbon on the left from CO2 and 2 carbons on the right, giving us 3 carbons in total. For hydrogens, we have 5 of them on their own and 1 of them forming a hydroxide, which gives us 6 hydrogens in total. Okay? Lastly, there are two oxygens to the left and one oxygen as a hydroxide to the right, giving us a total of 3 oxygens. Now that we have identified the number of elements on each side, we can see that the equation is still not balanced. In order to do that, we need to make it so that both sides will have 6 carbons, 12 hydrogens, and 6 oxygens respectively. Notice that if we multiply the quantities of elements on the right side, it will equal the number of elements on the left. So let's just erase these and put 2 here. Putting 2 there as a coefficient will enable us to double all the number of elements present in ethanol. Now, to calculate the total number of carbons, we need to get the 1 carbon from CO2 and add it to the quantity of 2 times 2, which will give us 5 carbons in total. Now, why the quantity 2 times 2? It is because the coefficient of ethanol now is 2. And since there are only 2 carbons present in ethanol, it's going to be the coefficient 2 multiplied by 2 carbons, which is 4. And we all know that 1 plus 4 is basically 5. So that means it has 5 carbons in total because you added a coefficient of 2 to ethanol. Now, for the hydrogen, we just simply apply that concept. So the coefficient is 2, so we will have 2 multiplied by 5, 5 being the hydrogen present as its own thing in ethanol, and 2 times 1 to the hydrogen that is present as a hydroxide that is bonded to oxygen. So 2 times 1, 1 being the 1 hydrogen in the hydroxide, is equal to 2. So 2 times 5 is 10, plus 2 times 1 is 2. So 10 plus 2 is basically 12 hydrogens in total. Now lastly, for the oxygens, we'll simply get the 2 oxygens present in carbon dioxide and the quantity 2 times 1. We will add it to the quantity 2 times 1 because, again, the coefficient of ethanol is 2 and there is only 1 oxygen present in ethanol. So 2 times 1. So 2 times 1 is equal to 2 and 2 plus 2 is just 4. Okay? Now that we're done with this balancing attempt, it can't be seen. No, it can be seen that the quantities on the left and the right of the equation is still not equal. That is why we need to do more balancing. Now, let's try erasing these and putting a 2 beside CO2 and see if this balances the equation. Now, for the carbons of the product side or the right side, we will have the quantity 2 times 1. 2 times 1 being it is from the carbon dioxide, right? So in the carbon dioxide, there's basically only 1 carbon present, and the coefficient of the carbon dioxide now is 2. So 2 times 1 is going to be the quantity. And then we just need to add that quantity with the quantity of 2 times 2, which is the coefficient 2 of ethanol, multiplied by the number of carbons present within ethanol, which is also 2, which will give us in total a carbon number of 6. So in total there are 6 carbons. Okay? Then for the hydrogen, since the hydrogen is only present in ethanol, we just need to copy what we did earlier. And it's going to be still the same. It's 12. Because if you're already right there, that means you don't need to change it at all because you just basically did the same thing earlier, right? So it's still 12. Okay? Now, for the oxygen, of course, it's gonna change because carbon dioxide also has oxygen and you put the coefficient 2 there. So basically now, we just need to multiply the coefficient 2 to the 2 oxygens present in carbon dioxide and add that quantity, not multiply, add that quantity to the quantity of 2 times 1. 2 being the coefficient of ethanol and 1 being the only oxygen present in ethanol, which is 1, as I said. Okay, now adding those, solving for that, we will have 6 oxygens in total. Now, after solving, notice that the quantities are now balanced, which gives us the proper formula for the fermentation, which is C6H12O6 or glucose yields 2 carbon dioxides or 2 CO2s and 2 ethanols or 2 CH2H5OH. Yes. Okay. Now, why do we need to express chemical equations in a balanced manner? Well, mathematically, It is basically because of the rule of equality for an equation. But most of all, so it does not prove wrong according to the law of conservation of mass, which states that the mass of the chemicals within a reaction cannot be increased or decreased, created nor destroyed, which is kind of similar to the first law of thermodynamics, which states that energy cannot be created nor destroyed. So it has to be transferred somehow. But for our case, for glucose to be balanced, it releases two carbon dioxide and two ethanols. So it follows the law of conservation of mass. Okay? Now that's out of the way, you may know now that the fermentation process is very complex. If you look into it in a closer perspective, right? Well, yes, it is complicated. It doesn't mean that it can't be simplified. So let's just scratch this for now. There we go. Now, as we discussed earlier in the balancing arc, alcoholic fermentation is a biological process that converts sugars into alcohol, specifically ethanol and the compound CO2, with the help of yeast. This process is commonly used in the production of alcoholic beverages such as beer, wine, and spirits, as well as in baking to make bread rise. In our process earlier, the first step was the preparation of the liquid, which was the grape juice. Notice that we did not add any sugar because the natural sugars within the liquid is already enough for the yeast. Then after we measured out, transferred the grape juice to our vessel, notice that we then added the yeast. This process is called inoculation, where the yeast are introduced to this sugary environment, which is the grape juice in our case, that starts the fermentation. Now, after the yeast has been introduced to its new sugary environment, the fermentation consequently begins. The beginning of the fermentation cycle is glycolysis, where the yeast breaks down the glucose in the juice that produces ATP, or adenosine triphosphate, which is the key compound that enables organisms to live. This process, however, needs some ATP to kickstart itself. This process yields about 2 ATP, 2 NADH, and 2 pyruvate per glucose molecule. The pyruvate in this process is actually just process intermediate products, which is then decarboxylated, which produces some carbon dioxide and 2 acetaldehyde. After the acetaldehyde is produced, it goes under a process called dehydrogenation, where the hydrogen is removed, which oxidizes the NADH and converts it into NAD+, producing ethanol, a waste product. Normally, the duration of the cycle varies on how you utilize it, but usually it stops happening when all the glucose has been depleted. That prevents the yeast to replenish all of the NAD plus they need for the respiration process, causing them to die out. The fermentation also stops when the yeast's environment is exposed to extremely low and extremely high temperatures. So now you know how to make wine yourselves and how the process itself works. Science really is a wonderful thing. Well, hello there. Yes. So, welcome to the wine tasting. I am Zeus Tesoro, your fermenter. So, this is the finished product of our wine. This wine is made from the Welks brand grape juice. It's bottled and well fermented. Or is it? We're gonna find out. And to compare the taste, the appearance, and also the alcoholic content, if there is any, because I doubt it fermented, there was no bubbles. I brought this playful thing, real wine from Woomera. It's an Australian brand from Southeast. Anyways, let's make this a better atmosphere. Starting with some flowers. slide that up. Ah, yes. Oh, yeah. Now, so this wine right here is made out of grape juice. So you would expect that it's a red wine. So wine is basically an alcoholic drink that's made with grapes. Yes, grapes that are fermented with yeast. And for a few weeks it will be fermented. So while the yeast digests the sugars in that grape juice, which produces the alcohol ethanol present in most alcohols. And now we're about to find out if it fermented, so let's just free it from its bonds. The dust really enhances the experience. Let's see. That's different. It changed colors. As you would remember, if you remember, the wine, the grape juice that we used was very dark. This, you can see through it a little bit. It's translucent now. Now, let's compare it to the real thing produced by fine wineries, shall we? Pressure. As you would expect, it's alcoholic. Look at that. No, I'm not gonna. Anyway. First, let's taste this one. We'll taste that one last, so we can compare. It's good. It's fine. That's a bad idea. It will catch on fire. Don't do that. Now let's compare this. As you can see, the biolock held itself together and it's off. So I don't see any yeast powder on the bottom. That's good. Oh my god. Damn, that smells like wine. I'm surprised. That is interesting in a kind of crap way. It's so far the same. Let's pour it. There's no residue. I'm surprised. It tastes more like a chemical. It tastes more like alcohol. So this definitely has more alcohol to fruit ratio, to fruitiness ratio. This, I don't know how they did it, but they actually preserved the grape flavor as well. It's fruity, vibrant, compared to this. Yeah, there's a difference. Okay, so the difference between the two wines I had just now is, first, when I tasted it, this one is more fruity and this one is not. Okay, this is more fruity and this one does not give any hint of wild fruitiness. It's just barely. If you took a cup and filled it with some rubbing alcohol and then put a teaspoon of grape juice. That's what it tastes like. The homemade wine tastes like alcohol mixed with a teaspoon of grape juice. Well, this one, the Woomera, this Woomera brand wine, it's very fruity and fit for consumption. Yeah. The smell, as for the smell, this one takes the cake. It's more vibrant. The same with this taste. And this one, again, like the taste, it smells mostly like alcohol. Overall, I prepare this, but if you're feeling adventurous, try making some homemade wine. And I hope you enjoyed the video. I shouldn't probably, yeah, it's alcohol, it's flammable. What's wrong? Okay. Anyways, that's it. Thank you for watching the video, and I hope that this helps you identify what cheap homemade wine is and what quality wine should be.